Hi, thanks for joining us for today's Impact Spotlights hosted by Hackster. My name is Dominick Lee, and it's my pleasure and honor to share with you our award-winning project, OmniFetch. So OmniFetch is essentially our award-winning hackathon project. It is a hands-free gesture-controlled robotic assistant for hazardous material handling and teleoperated industrial delivery. This project was built as part of a 36-hour hackathon hosted by Seeed Studio, Hackster IO, and NVIDIA. And of course, right here is my team. Together, we are a group of passionate engineers at Circuit Launch. We're also mentors. On the right side, we have a photo of our innovation here, and we're demonstrating it to a group of audience members and judges. Now, with that said, let me tell you a little bit more about myself. So, as you know, I'm an avid inventor, programmer, designer, and engineer. And I run a tech startup in California that provides a patented wearable technology which enables users to seamlessly control electronics, computers, robotics, and more with the flick of the wrist. And this patented award-winning technology enables users not just to control robots, but to feel empowered and control them from a safer distance. Now, aside from that, I'm also a roboticist in residence at Circuit Launch. Circuit Launch is an innovation hub that provides labs and facilities for robotics companies and startups. So as a roboticist in residence, I've helped various clients realize their dream use cases, especially when it comes to robotics, wearables, CAD design, and IoT-based platforms. Additionally, I'm also an honored alumnus from Purdue University, and I used to be the former club president of Purdue Mechatronics Club. It's always my passion to be able to help and lead where I can. In collaboration with Purdue University, one of my projects, the GyroPalm Impact Framework, which controls robotics, enabling them to be controlled by AR glasses and our one and only GyroPalm technology, has been featured and supported by the National Science Foundation. And some of my other works, such as the Lightbeam Flight Simulator, various workshops that I've led, as well as my discussion, my talk at Circuit Launch about AI and robotics. These are some key highlights that I'd like to share about just things that I've done for the community and things that I passionately would continue doing as part of just exploring what's possible in the realm of innovation, robotics, and automation. Now, another thing that I'd like to share, which inspired me to build the project behind OmniFetch, is our GyroPalm Spectrum product. It is actually something that's available on the market today, and it comprises of market-leading Vuzix AR glasses along with a GyroPalm wearable, all enclosed in the waterproof case. Now, this product is able to drive different robots. As you can see here, we have it driving the Boston Dynamics Spot. One of our colleagues has the Boston Dynamics Spot, and we're able to drive it from a far distance. And you can see on the corner of your eye, you'd be able to visualize the operator's view, see what the robot sees, and just explore remote areas without actually being there. So this is a very powerful tool, and it actually won the most promising innovation of the year at Sensors Expo. For those of you who don't know, Sensors Expo is North America's largest electronics design event for engineers. And so it's also an honor for them to feature me on their front page as well. Now, let's talk about the innovation at hand. So the OmniFetch. OmniFetch is a hands-free robotic object transport mechanism. So what this means is, well, most AMRs or autonomous mobile robots, they're large and they're not able to grab objects on shelves. They're not able to move things efficiently. And typically a mobile robot has what we call a docking variance of up to 2 to 4 inches. That means without AI and without robotic arms, it's very difficult for an AMR robot to carry things. And what we've done is we've added intelligent robot arms, right? The LeRobot arms. And we've been able to drive this robot along with those arms using cutting edge AI technology. All right, with that said, we can share with you a little bit more about putting together the pieces and how we built this during the hackathon. To even begin with, we needed preparation for the hackathon beforehand. So we obviously had the OmniBot V2, the V2 AMR here, and we also have the Seeed Studio Recomputer Mini, which was lent to us during the hackathon, and as well as the Seeed Studio LeRobot Arm 100. So these were things that we have mounted on the robot and prepared. In addition to that, we also have the GyroPalm Developer Kit. This is the official GyroPalm DK2, and it includes the wearable, receiver base, and so forth. And this allows us to drive the robot and train it for SLAM mapping and navigation. And of course, you can't do simultaneous localization mapping without the LiDAR, right? So we have the SlamTech S2L LiDAR, and we also have a custom wooden base, which I've CNC'd beforehand. This is something that fits right on top of the robot and allows it to mount various robotic arms and carry different payloads. Now, we also have two of these USB cameras. So basically, these two cameras are mounted on top of each LeRobot so that you have a clear view of what's being displayed here. And you can use that as training data for the algorithms and for training the model, essentially. We also have plastic trays and objects. And this is obviously the items that are being experimented with. Now, the LeRobot arm offers impressive precision, but to achieve that, we had to build this into the calibration sequence and to have to modify the servos in a way that enables it to pick up objects efficiently. So as you can see here, we use plastic bins so you could distinguish where objects are placed. Also, my team and I performed this during a 36-hour hackathon. So we had the pleasure of meeting with some leaders from NVIDIA who were very impressed with our innovation, as well as a quick shout out to Alex, the CEO of Circuit Launch. Now, our ACT model was trained using collective motion data to predict the arm trajectories, right? This would enable the robot to go to the predicted object locations, even if these are displaced or misaligned. And we wanted to adapt to various situations. So that means in different lighting conditions, we need to ensure the robot refines its skills. And so we had to train about 20 to 40 samples to begin with, and we scaled it up from there. As for the training, we trained it with a model, the ACT model initially, which is the action chunking transformer that enables it to record different episodes and play them back. Now, in the future, obviously, we will improve the stability with a hybrid mixture of models that have more grounding to it. The current model, though, is very reliable for the most part, and it's able to drive to different places and pick up objects. With that said, let me actually show you the video that we've presented, and this will give you a better idea of the demonstration.
Introducing Project OmniFetch, a hands-free gesture-controlled robot assistant for hazardous material handling. This project leverages cutting-edge technologies to create a hands-free, remotely operated robot assistant capable of picking up and transporting critical or hazardous objects in unpredictable environments. By combining GyroPalm gesture control, intelligent object manipulation, and dynamic teleoperation, we've created a solution that tackles latency issues common in remote control systems, while improving accessibility for those with disabilities or reduced mobility. Our project integrates a LeRobot open-source robotic arm mounted on an OmniBot V2 mobile-based platform. Our solution has the ability to dynamically pick up objects, even if displaced or rotated, making it an ideal solution for handling hazardous materials, assisting disabled users with medication retrieval, or serving as a tabletop butler in busy work environments. Prior training is performed by the end user on various objects to demonstrate proper robotic gripping behavior. After dozens of samples, training was initiated on an NVIDIA-powered GPU computer running CUDA. Using the ACT, or Action Chunking Transformer policy, we are able to have the gripper dynamically locate objects at the closest table or workbench surface and move them onto the robot for further transportation to a designated waypoint. The OmniBot then autonomously drives to the designated location, or optionally can be driven by a human operator using gestures with the GyroPalm Encore wearable. We hope our project inspires further advancements in accessible robotics, leveraging hands-free control and adaptive learning to create smarter, more responsive machines that empower human operators while accurately accommodating for imperfections in the robotic control paradigm.
All right. As you can see, this robot is very effective and it's become a proven project that showcases intuitive and reliable object handling using AI and gesture control. So we're currently in close works with Purdue and some industry leaders to bring this technology to more labs and facilities. And this robot can be flexibly upgraded with better robotic arms in long term. With that said, we appreciate you for your time. If you're interested, feel free to visit our Hackster.io project page, as well as our profiles, and feel free to give us a like on social media and follow us for more details. If you're interested in an OmniBot V2 AMR for your facility or lab, or buying some GyroPalm Spectrum kits, feel free to reach out to me directly at dlee@gyropalm.com. Thanks for watching.